Hello, I'm Lou Bloomfield and welcome to How Things Work at the University of Virginia. Today's topic, bumper cars. Like many amusement park rides, bumper cars involve almost as much physics as they involve fun. A bumper car is a small electric vehicle that is surrounded on all sides by rubber bumpers. Those bumpers are essential because collisions are unavoidable in bumper cars. In fact, the whole point of driving a bumper car is to crash into as many other cars as possible. If you've never seen bumper cars, picture a rectangular or oval floor surrounded on all sides by a wall, a padded wall, one with bumpers on it. That's the arena for bumper cars. And driving around this arena are about 20 little electric cars, each just big enough to hold one or maybe two people. Every car has a steering wheel and a motor that's controlled by a pedal, so it resembles a little car, or more like a golf cart or something. And the drivers drive around that arena wildly and smash into one another frequently. It's a blast. Not surprisingly, the bumper cars are designed to move relatively slowly, and their passenger compartments have lots of padding. Still, you can experience some pretty intense impacts, and it's those impacts that I'm going to be talking about in this episode. When two bumper cars collide, they typically exchange some energy, so that we've seen, but they also exchange two other conserved physical quantities, momentum and angular momentum. Those conserved quantities are new to us, and they are so important in bumper cars that they won't be so new by the end of this episode. As great as it would be to have a bumper car arena at the University of Virginia, I didn't manage to make that happen this semester. So I'm going to have to make compromises. But don't feel too sorry for me. To start with, I have these great little miniature hovercraft. I actually have 4 of them. And they can zoom about the table and bump into one another. Boing, boing. Collisions galore. They're perfectly good bumper cars if you happen to be a gerbil. But I also have a miniature bumper car arena. Ha ha ha. Look at this. Okay, it's actually a small air hockey table, but there's no real difference. I can send discs around this arena and have them crash into one another. Look at that. Woohoo! And there's pretty much everything there that you would see in bumper cars except for laughing children. So, using these cars, these guys, and my little arena, we can examine the important roles that momentum and angular momentum play in collisions. And we can study the processes whereby those quantities are transferred from one object to another. And although we'll examine them now in the context of bumper cars, momentum and angular momentum will reappear in everything from roller coasters to rockets as we continue to look at how things work. At this point, I'm going to pose a question and ask you to keep it in mind as we explore bumper cars. So, hopefully you have seen or ridden on a playground merry-go-round, one of these surfaces that you can spin and whip yourself around in a circle. The question is this: if you're riding a playground merry-go-round and you climb to the center of that merry-go-round, from the outside edge to the center, how will that affect its rotation? To help guide us through the science of bumper cars, we'll pursue 5 how and why questions. Does a moving bumper car carry a force? How is momentum transferred from one bumper car to another? Does a spinning bumper car carry a torque? How is angular momentum transferred from one bumper car to another? How does a bumper car move on an uneven floor? There's one video sequence for each of those questions and a summary video at the end. Now, on to the first question.